Hello my dear children, I hope all of you are doing great and I am back with the fourth video and the final video of the video series on understanding elementary shapes, class 6th science, and in today's video our agenda is to learn about quadrilaterals, and quadrilaterals are very important and cannot be missed. So please make your concept crystal clear by watching this entire video. And if after watching the video you feel that your concepts really got cleared, do not forget to mention in the comment section that concepts crystal clear. So let's get started. So let us now talk about quadrilateral in more detail, because as I said that in quadrilateral itself you get to see a lot of varieties. So as I discussed, quadrilateral means it is a polygon with 4 sides. So your blackboard is a quadrilateral, the cover of your book is a quadrilateral, bed is again a quadrilateral because you have 4 sides, 1, 2, 3 and 4. Your mobile phone is a quadrilateral with 4 sides. So what is a quadrilateral? Polygon with 4 sides. So how do we name a quadrilateral? We call it quadrilateral ABCD. Now sometimes when we want to write it in short, we often write it as QUAD, quad ABCD, which means quadrilateral ABCD. But as such, there is no symbol for quadrilateral like how we have it for a triangle. Now, the important parts of quadrilateral would be sides, vertices, angles and diagonals. So here on the screen we have a quadrilateral ABCD. So can you name the sides of these quadrilateral? Of course, the sides would be AB, BC, CD and DA, the 4 sides of the quadrilateral. What are the vertices? The 4 points where any 2 sides meet. So these 4 points are point A, B, C and D. What are the angles? So here angle A, angle B, angle C and angle D. So these are the 4 angles of the quadrilateral. What about the diagonals? Diagonals, line segment joining non-adjacent vertices. So which are the non-adjacent vertices? A and C are non-adjacent vertices. Similarly, B and D are non-adjacent vertices. So there are only 2 diagonal possible, that is AC and BD. So let's now talk about the types of quadrilateral. Now, you might be wondering that all quadrilaterals will have 4 sides. So now on what basis are we going to differentiate quadrilateral into different types? Well, now what we are going to judge is if all the 4 sides are equal or not, if all the 4 angles are equal or not. So depending upon the properties of the sides and the angles, these quadrilaterals are divided into following types. Square is a quadrilateral because it has 4 sides, but the speciality of square is that all the sides are equal in length, all the angles are equal in measure. So that makes it a square. You talk of a rectangle, here also all the angles are equal, but in this case all sides are not equal. So that is a rectangle. If you talk about a parallelogram, so parallelogram, the name itself comes from parallel. So parallelogram is that quadrilateral where not all angles are equal, but yes, the opposite sides are parallel and equal. So the opposite sides are parallel and the opposite sides are equal. Talk about a rhombus. In rhombus again all the sides are equal. So you might ask that okay, then what's the difference between a rhombus and a square? Now in square all sides are equal plus all angles are equal, but in a rhombus all angles are not equal, only all sides are equal. You also have a trapezium where the opposite sides are parallel but not equal. And the non-parallel sides, like these 2 sides, these are non-parallel sides but they are equal. So you see, based on the equality of the sides and the angles, we have been able to divide quadrilateral into so many different types. So let us look at the properties of each type of quadrilateral. So we start with a parallelogram. As the name suggests, parallel, it means opposite sides are equal, opposite sides. Now, as the name is parallelogram, that means something is parallel here. And what is that something? The opposite sides. So here opposite sides are equal, but they are also parallel. So that's like the basic thing. The opposite sides are parallel, That is why they are called parallelogram. Also, opposite sides are equal in length. That means this side is equal to this side is equal to this side. Opposite angles are also equal. So if let's name the parallelogram. Let's say ABCD is a parallelogram. So which would be the opposite angle of A? Angle C would be opposite of A. That means angle A is equal to angle C. Similarly, angle B is equal to angle D. So that is what we mean when we say opposite angles are equal. Diagonals bisect each other but not equal. So what would be the diagonals? BD will be a diagonal. Similarly, AC would be another diagonal. So as far as the diagonals are concerned, AC is not equal to BD, but they bisect each other. That means let's say that these two diagonals, they intersect at point O. So they bisect each other. That means one diagonal intersects the other diagonal exactly at the midpoint, such that ODO is equal to OB. Similarly, AO is equal to OC. That is what we mean by bisect. So diagonals length are not equal, but they intersect each other in such a way that they bisect each other. Now, can you think of making a parallelogram on your own? So yes, you can take help of the set square inside your compass box, and using the set square, if you set them like this, in this arrangement, you get a parallelogram, because in this case, your opposite sides become parallel and equal because both are identical set square. So if you take two identical set square, this is the arrangement that you would get. So in order to make this parallelogram, what we have done, two identical set squares. So this length is equal, this length is equal to this length. So opposite sides are equal. Also, the opposite sides are parallel because the distance between the opposite sides remain constant throughout. So that's how you can make a parallelogram. Rectangle. So in rectangle, all angles are equal, that is 90 degrees. So if we say that this is a rectangle ABCD, so in this case, angle A equal to angle B equal to angle C equal to angle D is equal to 90 degrees. So that is the first property of a rectangle. Next thing is opposite sides are parallel and equal. So this is something which is in common with parallelogram. So the opposite sides are equal in length, that is AD is equal to BC, and also AB is equal to CD. So the opposite sides are equal in length, and they are also parallel to each other. Diagonals bisect each other. So in this case also we see that the two diagonals divide each other into equal halves. Diagonals are equal. So this is something new, that diagonals are also equal. That is AC is equal to BD. So now when you look at the properties of rectangle, do you see any similarity between rectangle and parallelogram? Yes, if you look at the second and the third property, these two are common between rectangle and parallelogram. So is there any property which is extra in case of rectangle? Yes. So the first property and the fourth property. So the first property is all angles are equal. So this is a special property of rectangle. So there was no such requirement in case of a parallelogram. So we can say that rectangle is like a special type of parallelogram, because rectangle satisfies all the criteria to become a parallelogram, because these are the criteria to become parallelogram. But a parallelogram doesn't satisfy all the criteria to become a rectangle. So therefore we can say that rectangle is a special type of parallelogram. So all rectangles are parallelograms, but all parallelograms are not rectangles. So how can we make rectangle using set square? So again, with two set square you can make a parallelogram, but in this case you have to arrange the set square in this fashion. So which type of set square I have taken? So I have taken two pieces of 30, 60, 90 set square. So the set square whose two angles are 30 degree and 60 degree and 90 degree respectively. So two such set squares arranged in this fashion such that each angle is equal to 90 degree. Square. Now square is another wonderful thing. Here all the sides are equal, all angles are equal. So pretty simple to remember, everything is equal. So if ABCD is a square, in that case AB is equal to BC is equal to CD is equal to DA. And also angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. So each angle is 90 degree and all sides are equal. In this case, diagonals are also equal, that is AC is equal to BD. Diagonals bisect each other, that means the diagonals intersect each other at their midpoints such that DO is equal to OB and AO is equal to OC. Now looking at the properties of square, what do you think? How is a square like a rectangle like? Is there any similarity between a square and a rectangle? So this property is common between both of them. All angles are equal. All angles in rectangle also is 90 degree. Their diagonals are equal, that is also a common property. Their diagonals bisect each other, that is also a common property. So you see, except the first property, all other properties are same between square and a rectangle. So in this case, if you see, you would feel that a square satisfies all the criteria to become a rectangle, right? But a rectangle doesn't satisfy all the criteria to become a square, because in rectangle there is no such condition that all the sides should be unequal. So in rectangle there is a condition that opposite sides should be parallel, opposite sides should be equal. So in this case, opposite sides are parallel, opposite sides are equal as well, right? So that means square satisfies all the criteria to become a rectangle. So we can say that square is like a special rectangle. And since rectangle is already a special parallelogram, so square is also a special parallelogram, because square satisfies all the conditions to become a rectangle, all the conditions to become a parallelogram. In fact, besides that, square has some extra property, like all sides should be equal. So how can we make a square using set square? So we can take two set square, but this time the set square that we are going to take is the 45, 45, 90 set square. Why so? Because in this type of set square, the length of this side and this side is same. Because in a square, all lengths should be equal, all the sides. Therefore, we take 45, 45, 90 set square. Now, there is another interesting property of square, and that is the diagonals are perpendicular to each other. That means the diagonals not only bisect each other, they also bisect each other at 90 degrees. Next one, rhombus. So what's a rhombus? Here also all sides are equal, but the angles are not equal. So that's how a rhombus is different from a square. See, in this case also the diagonals bisect each other. So if let's say that if ABCD is a rhombus, then the diagonals AC and BD, they bisect each other at point O, such that BO is equal to OD and AO is equal to OC. Diagonals are not equal. So again, that is another point of difference between rhombus and square. Diagonals are not equal. Here angles are also not equal. However, diagonals are perpendicular to each other. So here also these diagonals are at right angles to each other. So how can we make a rhombus using a set square? So to make a rhombus, we need 4 set square, because this time we do not want the angles to be 90 degree. So therefore we take 4 set square like this. So which set square did we take? Again, we have taken 30, 60, 90 set square. Now we have arranged 4 set square in this fashion such that this side of all the set square are equal in length. So therefore all sides are equal, but at the same time these angles, they are different. So all sides are equal, but all angles are not equal. Finally, the last quadrilateral, that is trapezium. So what is a trapezium? So the speciality of trapezium is that here one pair of opposite sides are parallel. Please make a note of it, that one pair of sides are parallel, not both the pairs. So which are the 2 pairs of sides which are parallel here in this trapezium ABCD? So here if you see, AB is parallel to CD. So they are not equal, but they are parallel. Whereas the other pair of opposite sides are not parallel. So here there is a condition that only one pair should be parallel and the other pair should not be parallel. But the non-parallel sides are equal in length. That's another interesting thing, that the non-parallel sides are AD and BC. So they are equal in length. So a trapezium is always kind of noted by one pair of parallel sides and other pair of equal sides. So that is how we distinguish a trapezium. Here diagonals are equal. So if you draw the diagonals AC and BD, these would be the two diagonals. So we see that AC is equal to BD in case of a trapezium. So with this, we learned the properties of various types of quadrilaterals. Now it's question time. Question number 1. Give reasons for the following. A square can be thought of as a special rhombus. So can you think square as a special rhombus? Yes, we can, because a square satisfies all the criteria of a rhombus. That is, all sides are equal. So all sides are equal in a square, but with addition to that, square has some special features like all angles are equal. So a square satisfies all condition of a rhombus, therefore square can be thought of as a special rhombus. A square can be thought of as a special rectangle. Yes, of course, square is a special rectangle, because again square satisfies all conditions to become a rectangle. Like, what are the conditions you need to become a rectangle? In a rectangle, all angles should be equal and each angle should be equal to 90 degrees. Opposite sides should be equal. Opposite sides should be parallel. So these are some of the criteria needed to become a rectangle. So we see that a square satisfies all the criteria to become a rectangle. In fact, besides that, square has some extra features. For example, in a square, all the sides are also equal, all the diagonals are also equal. So those are the extra features in a square. So yes, a square can be thought of as a special rectangle. A rectangle can be thought of as a special parallelogram. Yes, of course, because what are the criteria to become a parallelogram? Opposite sides should be parallel, opposite sides should be equal, and a rectangle satisfies those criteria, and on top of that, a rectangle has some extra feature. What is that extra feature? All angles are equal, which is not so in case of parallelogram. So we can say that a rectangle is also a special parallelogram. Question number 2. Examine whether the following are polygons. If any one among them is not, say why. So let's look at the first image. Now what are the criteria? The 3 criteria to become a polygon. First is it should be a simple curve. Well, this is a simple curve because it doesn't cross itself. Second is it should be a closed curve. But do you think this is a closed curve? This is not a closed curve, because you see it is open from here, it is open from here. So this is not a closed curve. So therefore this is not a polygon. And why not a polygon? Because this is an open curve and not a closed one. Second one. Here also let's match the criteria. First criteria, it should be a closed curve. Well, it is a closed curve. Second criteria, it should be a simple curve. This is a simple curve. Third criteria, it should be made up of only line segments. But here, it is not made up of only line segment because this is a curve. So this is also not a polygon because it is not made up of only line segments. Question number 3. Draw a rough sketch of a regular octagon. Octa means 8. So a polygon with 8 sides. It is a regular octagon. So all the 8 sides are equal in length. Draw a rectangle by joining exactly 4 of the vertices of the octagon. So if you consider these 4 vertices, 1, 2, 3 and 4. And if you join them like this, what do you get? You get a rectangle. So in this fashion, we can draw a rectangle inside an octagon. So now that we have learned so much about various types of shapes like polygons, quadrilaterals, triangles, angles, let's now talk about some 3-dimensional shapes. Now, what are 3-dimensional shapes? So what do we mean by it? Think of these examples. You think of this table, not only the picture of the table, but a real table lying inside your room. Look at the table. Look at a room. So when you look at the room, how do you define the size of the room? So if I ask you what is the size of your room, how would you tell me? So you need to specify 3 parameters to define the size of the room. And what are the 3 parameters? Length of the room, width of the room, and height of the room. So length, breadth and height, these are the 3 parameters which are needed to define the size of the room. So this is a 3-dimensional shape. This is not 2-dimensional. You cannot have the room on a piece of paper, like we have drawn it on a piece of paper, but the actual room, it has got 3 dimensions. So a paper is not a 3-dimensional shape. A sheet of paper is a 2-dimensional shape. So when you look at a sheet of paper, this is how it looks like. So it has length and breadth. So there is no height involved as such. So any such shape which involves 3 dimensions, length, breadth and height, they are categorized as 3-dimensional shapes. When you look at this table has its length, width and height. So without these 3 dimensions, you cannot specify the size of the table. Look at the car. So in this car also, you have the length of the car, the breadth of the car and also the height of the car. So again, 3 dimensions needed here also. Think of a house, one of the best examples. In a house also you have length, breadth and height. So all these objects are 3-dimensional objects, and now we are going to talk about some 3-dimensional shapes. Now, whatever we have discussed so far, whether it is a rectangle or a quadrilateral or a parallelogram, if you would have seen, they only had 2 dimensions, length and breadth. So that's it. You think of a kite, all of them, they do not have the 3rd dimension, which is height. But now we are going to talk about objects with 3 dimensions. So how can we differentiate 2-dimensional shapes from 3-dimensional shapes? So 2-dimensional figures will only have 2 dimensions, that is length and breadth. So I'll take one example and I will show you that how 2-dimensional objects can together make a 3-dimensional object. So this playing card, this is a 2-dimensional object. Why? Because we just have length and breadth to define its size. If this is the length and this is the breadth, so only 2 dimensions are needed to define the size of this playing card. Now when I talk about a 3-dimensional shape, it should have 3 dimensions, length, breadth and height. Now I will show you that how using multiple playing cards we can make a 3-dimensional shape. Let's say instead of 1 playing card, I take 7 playing cards and then arrange them like this. So I build a tower, and this tower, do you think it is 2-dimensional? It is not 2-dimensional, because this time you have its length, you have its height and you also have its width. So 3 dimensions are now needed to define the size of this tower which we have created. So what do we understand from this? That many 2-dimensional objects together can together form a 3-dimensional shape. So in simple words, 2-dimensional means you only need 2 parameters to define the size of that object. 3-dimensional means you need 3 dimensions or 3 parameters to define the size of that object. Now, these are some of the figures which we have learned so far, like rectangle, triangle, square, pentagon, circle, and all of these are 2-dimensional. You see, you talk about a circle, you talk about radius, diameter, chord, and everything is 2-dimensional. Another interesting way to distinguish between 2-dimensional and 3-dimensional is that 2-dimensional is like something which you can actually draw on a sheet of paper, even though we can draw 3-dimensional figures also on a sheet of paper, but with certain strategies. Let's say that if you have a bottle of water, if you keep that bottle of water on a sheet of paper, what happens? Does it lie along the sheet of the paper? No, it stands protruded out of the sheet of paper. That's because of the height of that bottle. That height is the 3rd dimension which doesn't get accommodated on that sheet of paper. Right? So that's how we can distinguish that the bottle of water is not 2-dimensional but 3-dimensional. So these are all examples of 2D figures. Now what about 3D figures? When you look at figures like a sphere, like think of a ball. A ball is not a circle. A ball is a sphere. Think of any ball that comes to your mind. Now when you keep a ball on a sheet of paper, what happens? Does the ball lie along the sheet of the paper? No, it stands protruded out of the paper. That's because of the height of the ball, the 3rd dimension of the ball. So it doesn't get accommodated on the plane of the paper. So paper is 2-dimensional. It just has length and breadth. So it cannot accommodate the 3rd dimension which the ball has. So sphere is 3-dimensional. You think of a cone. The best example of cone that you can think of is the ice cream cone. So if you think of that cone, if you make it lie on a sheet of paper in any way you want, do you think it will lie along the sheet of the paper? No. This will also stand protruded because this is again three-dimensional. You think of a cuboid like a matchbox. So that also has a height, a length and a breadth. Think of a cube, maybe the dice in your Ludo, when you play Ludo, the dice. So that's a cube. So that's not a square, that's a cube. So these are all examples of three-dimensional figures that we are going to discuss now. Now here we will talk about something more interesting. Now these three-dimensional images can be formed from two-dimensional objects. So we looked at the example of the playing card. So playing card was two-dimensional, but many playing cards together made a three-dimensional object. Similarly, when you take the example of cuboid, so we see that a cuboid which is three-dimensional, this cuboid can be formed, is actually formed from two-dimensional rectangles. So what are rectangles? Rectangles are two-dimensional shapes with length and breadth. Cuboid is a three-dimensional shape with length, breadth and height. So here we will see that how many rectangles can form a cuboid. So if you stack rectangles one after another, so this is our two-dimensional rectangle, and here we will build three-dimensional cuboid from a rectangle. So you kept one rectangle. Rectangle means just imagine a sheet of paper which is cut in the shape of a rectangle. So you place this and you keep placing more and more rectangles like that. So what do you end up getting? You end up getting a solid cuboid, because the moment you keep stacking rectangles, you are actually building the third dimension, which is the height. Right? Because here you only had length and breadth. So it was a two-dimensional figure. But in this case, since you kept stacking one after another, you got this third dimension. So length was already there. So length is still there. Breadth was already there. It is also still there. But this is the height which has come additional. So this is the third dimension which we have added by stacking the rectangles one above another. Now in a similar way, that was an example of a solid cuboid where it is not hollow from inside. You have something inside. So everywhere you have one rectangle, and so many rectangles formed a cuboid. You can even make a hollow cuboid using rectangles. Let's look at this example. So how do rectangles form a hollow cuboid? You see, this is how a cuboid looks like, a matchbox. So this is one face which is a rectangle. This is the bottom face which is again a rectangle. This is the back face which is again a rectangle. This is the side face, a rectangle again. The other side face, a rectangle again. And finally the front face, which is a rectangle. So in this case, you have a total of 6 rectangles which are arranged in this fashion to form a hollow cuboid. So what do we understand from this? We understand that doesn't matter in which pattern they are arranged, but two-dimensional shapes are only arranged in some or the other pattern to form a three-dimensional object. So to add further to this statement, let's take the example of a cylinder. So cylinder again is a three-dimensional object, and we will see that we can build a cylinder, a three-dimensional cylinder from a two-dimensional circle. So if you have a circle like this, and in fact you can do this at your home using coins. So coins are circular, right? But when you stack one coin above the other, you keep stacking multiple coins together, what do you get? You get a cylinder. So by stacking coins, you are actually building the third dimension. So that's how we see that the circle, which was a two-dimensional shape, many such circles gave rise to a three-dimensional cylinder. So with this, what we understand is whenever we talk about a three-dimensional shape, we just not talk about angles, sides and vertices, because there are a lot more to that in a three-dimensional object. So what are the basic parameters, or what are the basic parts of a three-dimensional object, of any three-dimensional object? And those three major parts are faces, edges and vertices. So what are faces? So let's take the example of a cuboid. So in a cuboid, each of these rectangles form a face of the cuboid. So when you look at it from the back, maybe you will be seeing this face. When you look at it from side, you'll be able to see this face. This side, this face. Front face is this one. So total, how many faces do you have in this cuboid? Just now we saw that there are total 6 faces in this cuboid, and each face of a cuboid is a rectangle. Right? So we can say that this is one face, this is one face, this is one face. So we can see 3 faces, and 3 faces are not visible. One is at the bottom, one is at the back, and one is on the other side. So total there are 6 faces in a cuboid. So whenever you look at any 3-dimensional object, each face of that 3-dimensional object would be a 2-dimensional shape. For example, in this case, the face of the 3-dimensional cuboid is a rectangle. So each face is a 2-dimensional rectangle. Perfect. Now we see that any 2 faces meet at a line segment. So that line segment is an edge. For example, let's call this as face number 1, face number 2, face number 3. So you see face number 1 and 2, they have one side in common, that is this side. So this side is an edge. Similarly, face number 1 and 3, they have this side in common. So this side is an edge. Similarly, 2 and 3 will have this side in common, and this is edge. So basically each of these sides, each line segment is termed as an edge. So these edges are the common line segments between 2 faces. Now when you look at this cuboid, how many edges do you have? Now when we look at a cuboid from the front view, we can see how many edges. So this is one edge. Let's call this edge number 1. This is edge number 2. This is edge number 3. This is edge number 4. This is 5. This is 6. This is 7. This is 8. This is 9. So 9 edges we can see. Do you think there are more edges? Yes, of course, because there is an edge somewhere here which is not visible from the front. So that is an edge. That is edge number 10. Similarly, there will be an edge here which would be a common line segment between this face and the bottom face. So this would be edge number 11. There would also be an edge here which would be a common line segment between the back face and the bottom face. So that would be edge number 12. So there are 12 edges in a cuboid. Now it is not very easy to say how many edges are present in a 3-dimensional figure, because it is not only about the line segments that you see, it is also about the line segment which are there but which you are not able to see. Right? So in this way we see that there are 6 faces and 12 edges in a cuboid. Now what about vertices? Now vertices are still the points where the edges meet. So you see that at every point there are 3 edges which meet. For example, edge number 5, edge number 1 and edge number 6, they meet at this point. Similarly, at this point, edge number 1, edge number 2 and edge number 3, they meet at this point. If you consider this point, edge number 6, edge number 7 and edge number 11, they meet at this point. So like that, how many points do you have? 1, 2, 3, 4, 5, 6, 7 and 8. So there are total 8 vertices, out of which 7 of them are kind of visible from the front view, but one which is here is not visible from the front view. So all in all, we can say that in a cuboid there are 6 faces, 12 edges and 8 vertices. So based on this basic knowledge on 3-dimensional shapes, let us try some questions. Question number 1. A cube is a cuboid whose edges are all of equal length. So the only difference between a cube and a cuboid is that the faces in a cuboid are rectangles, but the faces in a cube are squares. So now when you have all the faces squares, so that means that all the edges will be of equal length. So you have to tell how many faces, edges and vertices are there in a cube. So when you talk about a cube, all the sides are of equal length. So let's try to analyze the faces first. So this is front face, face number 1. So we will have similarly we will have a back face. So let us call that back face as face number 2. So face number 2 is the back face. So we will draw the back face with a dotted line. So this is our back face. So 1 is the front face, 2 is the back face. 3 is the top face. So this top face is nothing but a square. Similarly, you will have a bottom face. Let's call that 4. This is the side face, which is 5. So similarly, this side also you will have a side face, which is 6. So total how many faces? We have 6 faces, and each face is a 2-dimensional square. How many edges are there? So you see how many line segments? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 are clearly visible and 3 are hidden because they are on the back side. 1, 2 and 3. So total 12 edges. And how many vertices? How many points are there where the edges meet? 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 vertices. Question number 2. A square pyramid has a square as its base. Now what is a pyramid? So pyramid is a structure which is formed in such a way that you have a polygon base and then you have triangles as all other faces. So here you can see this is a polygon. So this is the base of the polygon, the square. This square form, let's name the square as ABCD. So ABCD is the base, and then you have these kind of triangular faces, and all these triangular faces get connected to a point at certain height. So that's how a square pyramid is made. So here also you have to tell the number of faces, edges and corners. Corners are nothing but vertices. Let's look at the faces first. So here we have the bottom face as square. So let's number the bottom face as 1. And then how many triangular faces you have? So there are 2 side faces triangular. So these are number 2 and 3. So there is one triangular face at the back. This triangular face at the back. And there is one triangular face at the front. This one is the front face. So that is 5. So total number of faces 5. So how many? Out of that 4 triangular faces and 1 square faces. How many sides do we have? Let's count the line segment. 1, 2. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7 and this is 8. So there are total 8 edges. How about corners? So this is one corner because here the edges meet. This is another corner, this is another corner, this is another corner and this is yet another corner. So there are 5 corners or 5 vertices. Question number 3. Match the following. So here we have certain images and we have to tell the name of each of them. So cone. How does a cone look like? So cone, whenever you think of a cone, think of an ice cream cone. So it is like a circular base and then you have a triangular top. And it can be the upside down as well. So this is a cone. Sphere. Sphere is your ball. So sphere is not a circle but it is made up of many circles. So many circles together, when they are stacked in a circular fashion, they make a sphere. Cylinder. So cylinder will have circular base, circular top, but in between it will have a rectangular body. So you see a rectangular body, circular top, circular bottom. Cuboid. So cuboid is just like the matchbox where you have rectangular faces forming a cuboid. Pyramid. Just now we discussed, now pyramid can be a triangular base pyramid or a square base pyramid. So here you have one base which is a polygon basically, and then from that base, from each side of that base, there is one triangular faces, and all those triangular faces, they get connected at a certain point. So here you see the base itself is a triangle. This is the base, this is one triangular face, this is another triangular face, and there is one more triangular face which is at the back, which is not visible to us. So this is a triangular pyramid. So if in case you are more curious to know or to visualize more three-dimensional shapes, you can refer the video on three-dimensional shapes of class 7 mathematics. So there we have done some practical demonstrations also to give you better visualization of three-dimensional shapes.
I hope you found the video useful. If you really liked the video, do not forget to share it with your friends. And if you think after watching this video, your concepts of this lesson became crystal clear, please do write in the comment section that my concepts are crystal clear. So I will meet you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.